what happens if we switch the methyl group for another carboxylic acid? How many stereoisomers are there now? Well, let's start with the obvious. Here are two stereoisomers. These isomers are non-superimposable mirror images. They're enantiomers of each other. They are optically active and chiral. The 2,3 carbon-carbon bond is rotated about 180 degrees. This new conformer has no internal plane of symmetry. Now, why is that an issue? What about another stereoisomer? Well, this one possibility has stereogenic centers that are 2s, 3r. This other possibility has stereogenic centers that are 2r, 3s. So enantiomers, right? Well, let's take a closer look. We will start by rotating the central bond by 180 degrees. This new conformer, very importantly, has an internal mirror plane. This plane of symmetry means that the molecule is optically inactive and achiral. Now we will rotate the molecule by 180 degrees about an axis perpendicular to the central bond. The central bond is rotated by 180 degrees to give the final conformer. Now, if this last conformer looks familiar, there's a reason for that. It is. A minute ago, it's what we were speculating made up the second molecule in a pair of enantiomers, when in fact they are not enantiomers, but merely conformers of the same molecule. The plane of symmetry is critical to understanding why. The presence of this plane makes the molecule Meso. Now, the two conformers had opposite stereogenic centers, 2s, 3r, and 2r, 3s. How come? Recall R and S are based on 4 components attached to just a point in the whole molecule, where the components are different from each other. Their calculation doesn't involve the entire molecule. The plane of symmetry critically means that we can rotate 180 degrees about the axis perpendicular to the central bond. Without this movement, we would not realize the conformer that initially seemed to have similarities to an enantiomer was in fact just another conformer. So in total, we have 3 stereoisomers, not 4. 2 are enantiomers of each other, whilst the third is meso, and is a diastereomer of either of the enantiomers.